So my presentation is based on the original article by Luke and Billie Snell published in Concrete International in December of 1996. I also want to thank the 1820 Colonel Benjamin Stevenson House for my outfit. This is a typical worker's outfit from the 1820s. You may have seen, if you were there on the Erie Canal when it was being constructed and or in use, the workers there probably were wearing something like this. So in 1800, this was the United States. The western boundary was the Mississippi River. But 3 years later, the country more than doubled in size with the Louisiana Purchase. And suddenly, everybody was wanting to go west, and those that lived out west were wanting to ship their goods to the east. The pink area is the extent of the settled area at that time, and although it shows roads on this map, travel was very difficult unless you were next to a river, and then travel was relatively easy. And of course, everybody started talking about building canals because that allowed people to move goods rapidly compared to over the land. So canals were nothing new. They go way back. If you go back to the Achaemenid Empire, Darius I was a big civil projects king, and back in the 16th century, he was building canals. In fact, he built one, or had one built, from the Nile to the Red Sea. In China, they began building canals quite a bit, starting in the 3rd century BC and onward. And one of the canals that they built was called the Grand Canal because over time, just like the Great Wall, they kept adding on to it. In Europe, canal building really took off between the 16th and 18th centuries, particularly in the Netherlands, France, and Germany. But it really was Great Britain that took canals to the next level. You can see in this map all the different canal systems that they had developed. So Britain started to build canals in the mid-1700s, but the canal building age took off really in the 1790s. They built many canals. And that was in conjunction with the Industrial Revolution because they were trying to ship goods. Most of the canals were funded by merchants, aristocrats, bankers, coal mine owners, pottery barons. They wanted an easy way to ship their goods. Many canals were built. Not all of them were successful. There were a lot of investors. They thought that by investing, then they would get a good return. And some of the canals were so expensive to build, nobody made any money. But there were some successful ones as well. Those that were successful tended to be very local in nature, and their effects helped the local economies. By 1850, there were approximately 4,800 miles of inland waterways in Great Britain, primarily in England and Wales. So in the United States, as I mentioned, they were looking for ways to improve transportation. This map shows some of the canal systems that were developed in the United States, including, they're up in the upper part of the picture, the Erie Canal, which went through the state of New York. And there it is in more detail. So the Erie Canal was completed in 1825. It connects Albany, Syracuse, and Buffalo. A later connection to Lake Ontario was provided by the Oswego branch in 1828, and then many other branches were added, one in particular to carry coal from Appalachia to the East Coast. It is still operating. It's the country's oldest continually operated canal system, and it's also the 200th anniversary this year, so it's kind of exciting to be able to present on the Erie Canal here to celebrate that. So this is the canal in detail. So the United States was only 40 years old when it was constructed. It was completed in 8 years. That's 363 miles in length from Albany on the Hudson River to Buffalo on Lake Erie. It's 40 feet wide and 4 feet deep. 83 locks. And although 4 feet deep doesn't seem like that's very deep, currently on the Illinois waterway and the upper Mississippi River lock and dam system, they have a 9-foot channel. So not 4 feet was pretty impressive for that time. No natural lakes or rivers were incorporated into its design at the time, so it was all canal construction. The cost was about $7 million, which in today's dollars, $230 million. So at a time in this country when there was no formal non-military engineering education available in the United States, the first civil engineering degree wasn't going to be awarded for several decades after this. And there were few who had any skills to design and build canals. How did the canal get built? Many other canals had been built in Great Britain and even in the United States. Many of them had failed. And when Thomas Jefferson was asked by those in New York to possibly fund this canal, he was looking at that past history and he says, "It's a splendid project and it may be executed a century hence. Think of making a canal 350 miles long through a wilderness. It is a little short of madness to think about it." So the United States Congress did not provide funding. However, New York didn't give up. In fact, Clinton DeWitt, he was a major promoter of the canal. He was mayor of New York City, and then he went on to be governor of New York. He really pushed for canal support. The people of New York, particularly along the proposed route, rallied, and they finally passed an act in 1811, which gave a group of canal commissioners authority to start planning what would be that 4-foot, 40-foot wide canal across the state. They got enough money collected, and they began construction on the 4th of July in 1817 in Rome, New York. So Benjamin Wright, he was a surveyor by training, and he had worked on a few other canals. So he was assigned to construct the middle portion of the canal, and within a year, he was assigned to be in charge of the entire canal construction. He spent so much time learning about how to build canals, even though he didn't have the formal civil engineering education, he eventually became known as the father of American engineering. He also was known as a member of the Erie Canal School of Engineering, because he and several other men who probably had similar backgrounds of surveying and had worked on canals learned how to build civil engineering projects, building the Erie Canal. He was also instrumental in mentoring many up-and-coming engineers, including Canvas White. So Canvas White became one of Wright's assistants on the Erie Canal construction. He didn't have much formal education, but based on what I read, he certainly tried to learn as much as he could. He studied mathematics, astronomy, chemistry, mineralogy, and surveying. When he was a young man, he wasn't very healthy, and so interestingly, to get his health back, he shipped out on a merchant vessel to Russia. And on the way back from that trip, the ship stopped in Great Britain and England, and that was during the War of 1812. But the people on the ship didn't know that the war had broke out. So the ship was quarantined in England for a short amount of time. But I guess the merchants that had goods that wanted to get them sold in the United States pushed to let the ship sail. They sailed, but then a storm came in and pushed the ship back onto shore. In fact, it pushed it way back on a beach. And so the ship was stuck in the sand. So Canvas White said, well, why don't we dig a ditch? And so when the high tide comes in, we'll be able to float the ship back out to sea. And sure enough, they did that. It took them several days to build the ditch. The high tide came in, the ship floated back out, and they were able to return to the United States. So he was already learning how to build canals even then. When he came back, he served in the war. And after the war was over, he was one of the first to apply for a position on the Erie Canal project. So while he was working on the project, he got to know Wright and also the governor, and they encouraged him to go to England to investigate the canal system, and he went in 1817. He spent about a half a year there. He traveled over 2,000 miles and inspected a variety of aqueducts, tunnels, locks throughout the British Isles. He studied, measured, and recorded the up-to-date canal system. He brought back the latest surveying and construction tools and instruments with him. But most importantly to us, he spent a lot of time investigating the properties and manufacture of hydraulic cement, which was going full blast in Great Britain at the time. Meanwhile, back with the canal, Wright and his assistants were debating what type of materials to use to build the locks on the canal. And they knew that the materials that they had on hand, regular masonry with lime mortar and wood, would deteriorate very rapidly. They knew that the British used stone and hydraulic cement and concrete. But importing hydraulic cement to the United States at that time was very costly and very inconvenient. Wright thought that maybe they could import some and just use it on the surface, but even then they knew that it wasn't going to work, and they tried the lime mortar and it started to deteriorate right away. So here comes White. He said, well, I know how to make hydraulic cement. I'm going to look for materials that will allow me to make that product here. So he searched around, and believe it or not, where they were building the Erie Canal, there were sources of material that was good quality for making hydraulic cement. So they were excavating the material that they could use to create cement. So he experimented extensively. He spent a lot of his own money, and he eventually began making a highly feasible product. He essentially originated cement manufacturing in the Western Hemisphere. His cement was made from stone ground in quarries at the Chittenango, Madison County, New York. Of course, his product was cheaper and better quality than that used in England. He got a patent in 1820, and 500,000 bushels of White's new American-produced waterproof cement were used in the construction of the Erie Canal. However, White's permission was not obtained, nor were the rights or royalties paid for the cement's use, even though they were using his patented cement. He filed several lawsuits. He won all of them, and New York was supposed to pay him for the use of his cement, but they never did. Well, I think he didn't pursue it too much because he was very busy building other canals, and he turned over his company, cement company, to his younger brother, Hugh. So Hugh greatly expanded the firm's operations and to different plants, including Rosendale, New York, Louisville, Kentucky, and Cumberland, Maryland. Their cement was used extensively in the construction of other historic American structures like the Statue of Liberty, the Brooklyn Bridge, and the U.S. Capitol. And to signify Canvas White's importance to the Erie Canal, this plaque was installed there along the canal. In summary, the Erie Canal was a huge and immediate success as a transportation artery. Goods traveled eastward and travel proceeded westward. Many towns and cities sprang up along the canal, including Syracuse, Rochester, and Buffalo. According to the state of New York, 80% of the population of upstate New York still lives within 25 miles of the route of the Erie Canal. And in the words of Luke and Billie Snell from their article in 1996, as the first concrete engineer of the United States, Canvas White was able to incorporate his natural cement into several other American canal systems. Solutions to the challenges of the Erie Canal construction enabled the country to expand at less expense. It also helped to develop young and bright engineers, and the manufacture of America's own natural hydraulic cement began with the Erie Canal. These are my references, or some of my references. And are there any questions?